Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper Math P3 Variant 2 May-June 2022. Let's get started. Antonio has a shop near the beach. He makes a tally of the number of ice creams he sells on Friday. Work out the number of ice creams he sells on Friday. When we count the number of strokes, we get 48. 15 of the ice creams he sells on Friday are vanilla. Work out the fraction of ice creams he sells on Friday that are vanilla. Give your answer in its simplest form. To get this fraction, we divide the number of vanilla ice creams he sells, which is 15, by the total number of ice creams he sold, which is 48. This simplifies to 5/16. He buys tubs of ice cream for his shop in the ratio vanilla is to chocolate equals 11:7. He buys 28 tubs of chocolate ice cream. Work out how many tubs of vanilla ice cream he buys. We've been given the ratio vanilla is to chocolate to be 11:7. We are also told he buys 28 tubs of chocolate ice cream, and we want to find the number of tubs of vanilla ice cream he buys, which is what we are calling y. When we cross multiply and make y the subject, this is what we get, which is equal to 44. Antonio records the number of chairs his shop hires out on each day for a week. Work out the range. The range is equal to the highest number, which is 165, minus the lowest number, which is 45. This gives us 120. Find the median. Before we get the median, we need to arrange the numbers in ascending order. To get the position of the median, we use the formula half n plus 1, where n in this case is 7. This gives us 4. The number in the fourth position is 116. Calculate the mean. The mean is equal to the sum of all the chairs he hired out for 7 days, which is 123 plus 98 plus 116 plus 45 plus 67 plus 165 plus 156 divided by 7. When we type this into the calculator, we get 110. Antonio buys beach balls for $2.5 each and sells them for $4.2 each. Work out the percentage profit he makes on each beach ball. His percentage profit on each ball is equal to the profit he makes on each ball, which is 4.2 minus $2.5 divided by the cost of a ball, which is $2.5 times 100%. This gives us 68%. A beach ball is a sphere with radius 15 centimeters. Calculate the volume of the beach ball. Give the units of your answer. We've been given the formula for the volume of a sphere to be 4/3 pi r cubed, where the radius r of the sphere in this case is 15 centimeters. When we type this into the calculator, we get 14,100 centimeters cubed, rounded to 3 significant figures. The shop sells sun cream in bottles A, B, and C. Work out which bottle is the best value. You must show all your working. First, we divide the volume of cream in each bottle by the cost of the bottle. From the results, we see that bottle A has the highest volume for each dollar paid, so this gives us the best value. Complete the table of values for y equals -6/x. When we plug in x equals -4 into the equation, we get y equals 1.5. For x equals -1.5, we get y equals 4. For x equals 1.5, we get y equals -4. And for x equals 5, we get y equals negative 1.2. On the grid, draw the graph of y equals negative 6 over x for x is greater than and equal to negative 6 and less than and equal to negative 1, and x is greater than and equal to 1 and less than and equal to 6. On the grid, we plot all the points in the table and connect the points with a smooth line. Write down the order of rotational symmetry of the graph. The order of rotational symmetry of the graph is the number of times the graph looks exactly like this when it is rotated through 360 degrees. The graph looks exactly like this under two instances: when it is rotated 180 degrees and when it is rotated 360 degrees. So the order of rotational symmetry is 2. Write down the equation of each line of symmetry of the graph. The line of symmetry of the graph is the line that splits the graph into two mirror halves. The graph has two lines of symmetry, y equals x and y equals negative x. On the grid, draw the line y equals 2.5. On the grid, we've drawn the line y equals 2.5, which is a horizontal line passing through 2.5 on the y-axis. Use your graph to solve the equation negative 6 over x equals 2.5. In other words, we are to find the x value of the intersection point between the graph of y equals negative 6 over x and the line y equals 2.5. On the grid, we see that the x value of this point is negative 2.4. Draw a line that passes through the point P and is perpendicular to line L. Using a protractor, we measure and mark an angle of 90 degrees at point P. When we are done, we draw a straight line passing through the 90-degree mark and point P. Find the equation of the straight line that is parallel to the line y equals 3x plus 5 and passes through the point 1, 7. Give your answer in the form y equals mx plus c. All we need to do is find the values of m and c for the line and plug in these values into y equals mx plus c. Y equals 3x plus 5 has already been expressed in the form y equals mx plus c. So the coefficient of the x term, which is 3, is the gradient of the line. Since the line is parallel to y equals 3x plus 5, then the gradient of the line would also be 3. To get c, we plug in the value of m and the set of coordinates through which the line passes 1, 7 into y equals mx plus c. This gives us 7 equals 3 times 1 plus c. 3 times 1 is 3. When we subtract 3 from both sides, we get c equals 4. So we have y equals 3x plus 4. Write down the mathematical name for the type of angle A. Angle A is between 90 degrees and 180 degrees, so it is an obtuse angle. Measure angle A. Using a protractor, when we measure angle A, we get 113 degrees. Kate describes a quadrilateral. All the sides are the same length. It has only two lines of symmetry. Draw a sketch of this quadrilateral. Here is the quadrilateral that fits Kate's description. Write down the mathematical name for this quadrilateral. The quadrilateral is a rhombus. One of the interior angles of this quadrilateral is 70 degrees. Work out the other three interior angles. Opposite angles in a rhombus are equal. So if one angle is 70 degrees, then the angle opposite this in the rhombus would also be 70 degrees. The sum of the angles in a rhombus add up to 360 degrees. So to get the other two angles, We subtract 2 times 70 degrees from 360 degrees and divide by 2. This gives us the other two angles to be 110 degrees. The diagrams show the angles in a triangle and two angles on a straight line. The triangle is used to write down an equation in terms of x and y. 2x plus 2y equals 180. Give the geometrical reason why this equation is correct. This is because the sum of the angles in a triangle add up to 180 degrees. Use the diagram with two angles on a straight line to write down another equation in terms of x and y. The sum of the angles on a straight line add up to 180 degrees, so we have x plus 6y equals 180. Solve these simultaneous equations. You must show all your working. First, let's label the two equations. We will be using the elimination method. We want to eliminate x, so we multiply equation 2 by 2. This gives us 2x plus 12y equals 360, which we've labeled as equation 3. Now that we have 2x in equation 3 and 2x in equation 1, we can eliminate x by subtracting equation 1 from equation 3. This gives us 10y equals 180. When we divide both sides by 10, we have y equals 18. So now we can plug in the value of y into any of the equations to get the value of x. Let's pick equation 2. This gives us x plus 6 times 18 equals 180. 6 times 18 is 108. When we subtract 108 from both sides, we get x equals 72. The diagram shows the net of a cuboid. Work out the area of the shaded rectangle A. Here is the formula for the area of a rectangle. When we close up the cuboid, these two sides come together. So the width of rectangle A is 5 centimeters. These two sides also come together at the top of the cuboid. So the length of rectangle A is 7.8 centimeters. This gives us 39 centimeters squared. The volume of the cuboid is 468 centimeters cubed. Complete the statement. Here is the formula for the volume of a cuboid. We already know two of the dimensions of the cuboid, so we want to find the third dimension. When we make L the subject, this is what we get. The volume V is 468 centimeters cubed. The width W is 7.8 centimeters and the height H is 5 centimeters. This gives us 12 centimeters. So the dimensions of the cuboid are 12 centimeters by 7.8 centimeters by 5 centimeters. A cylinder has a radius of 8 centimeters and a height of 12 centimeters. Calculate in terms of pi the volume of the cylinder. Here is the formula for the volume of a cylinder. We've been given the radius r to be 8 centimeters and the height h is 12 centimeters. 8 squared times 12 is 768. So we have 768 pi centimeters cubed. The diagram shows a circle with a diameter of 7 centimeters and a parallelogram with a base of 12 centimeters. The circle touches two of the sides of the parallelogram. Calculate the shaded area. To get the area of the shaded region, we subtract the area of the circle from the area of the parallelogram. The area of the parallelogram is base times height, where the base is 12 centimeters and the height, which is the same as the diameter of the circle, is 7 centimeters. The area of the circle is pi r squared, where the radius r is 7 centimeters divided by 2. When we type this into the calculator, we get 45.5 centimeters squared, rounded to 3 significant figures. Rebecca records the flight distance and the ticket price for each of her last 12 plane journeys. Complete the scatter diagram. The first 8 points have been plotted for you. On the grid, we plot the points 100, 120, 275, 170, 380, 310, and 540, 305. What type of correlation is shown in the scatter diagram? On the grid, we see that as the flight distance increases, there is a general increase in the ticket price. This type of correlation is positive. On the scatter diagram, put a ring around the point for the journey that has the highest price per kilometer traveled. The journey for this point has the highest price per kilometer traveled. Compared to the rest of the plane journeys, there is a big difference between the flight distance and the ticket price. You can confirm that this point has the highest price per kilometer by dividing the ticket price for each journey by the flight distance. On the scatter diagram, draw a line of best fit. On the diagram, we've drawn a line of best fit. The general rule of thumb for drawing a line of best fit is to ensure that it passes through as many points as possible while balancing an equal number of points above and below the line. The scale drawing shows two airports, K and L. The scale is 1 centimeter represents 50 kilometers. A plane flies in a straight line from K to L. Use the scale drawing and your line of best fit to find an estimate for the ticket price of the journey from K to L. First, we need to find the distance the plane covers from K to L. On the scale drawing, when we measure the distance between K and L, we get 6.5 centimeters. Using the scale conversion, we can get the actual distance between K and L, which is what we are calling x. When we cross multiply and make x the subject, this is what we get, which is equal to 325 kilometers. On the grid, when we map 325 kilometers from the horizontal axis onto the line of best fit, we get the estimated ticket price to be $235. Mr. V works in a bank. The travel graph shows Mr. V's journey from his home to the bank. Write down the distance Mr. V travels in the first 8 minutes. Mr. V leaves home at 7 o'clock. 8 minutes after 7 o'clock is 7:08. When we map 7:08 onto the graph, we get the distance covered to be 0.8 kilometers. Explain what is happening between 7:08 and 7:12. Between 7:08 and 7:12, Mr. V stops. Between which times is Mr. V's journey the fastest? Give a reason for your answer. Mr. V's journey is fastest between 7:12 and 7:24 because the slope of the graph is the steepest in this time range. Work out Mr. V's average speed for the whole journey. Give your answer in kilometers per hour. We can use this formula to get his average speed. From the graph, the total distance he covers is 6.4 kilometers and the total time duration for his journey is 24 minutes. To convert 24 minutes to hours, we divide 24 by 60. This gives us 16 kilometers per hour. Katia takes some coins to the bank. The table shows the number of each type of coin. Work out the total amount of money Katia takes to the bank. Give your answer in dollars. The total amount of money Katia takes to the bank is 1 cent times 12 plus 5 cents times 23 plus 10 cents times 17 plus 25 cents times 9 plus 50 cents times 7 plus 100 cents times 24, which is equal to 3,272 cents. To convert this to dollars, we divide 3,272 by 100. This gives us $32.72. Adam changes $700 into euros at the bank. The exchange rate is $1 equals 0.904 euros. Work out the amount Adam receives. We want to find the amount of euros Adam receives for $700, which is what we are calling X. When we cross-multiply and make X the subject, this is what we get, which is equal to 632.8 euros. Clara invests $8,500 for 4 years at a rate of 1.7% per year simple interest. Calculate the total interest earned during the 4 years. For simple interest, we can use this formula to calculate the amount of interest earned. The principal P is $8,500. The annual rate R is 1.7%, and the time duration in years T is 4. When we type this into the calculator, we get $578. Shade some squares so that both shapes have the same fraction shaded. For this shape, 5 out of 12 slices are shaded. This shape is made up of 36 squares. 5 over 12 of 36 is 15, so we shade 15 squares. Here is a pattern. Position number 1 is a big white circle. Position number 2 is a big black triangle. Draw the next 2 shapes in this pattern. After every big white circle, there is a big black triangle. And after every big black triangle, there is a big white rectangle. What do the position numbers of the shape have in common? From the pattern, we see that the position numbers of the small black rectangles are multiples of 4. Pierre says that the shape in position number 99 is a big white rectangle. Explain why he is correct. We know that the position numbers of the small black rectangles are multiples of 4. 100 is a multiple of 4. This means the shape in the 100th position is a small black rectangle. In the pattern, there is always a big white rectangle before a small black rectangle. This means a big white rectangle is in the 99th position. This universal set has 12 elements. Each shape is a circle C, or a triangle T, or a rectangle R, large L or small s, black B or white W. The triangles and rectangles are drawn in the Venn diagram. Draw the 4 circles to complete the Venn diagram. The intersection of B and C describes the elements that are circles and black in color. The remaining circles go into this region of the Venn diagram. Find the number of elements in B union C. From the Venn diagram, the number of elements in B union C are 8 in total. 6 of the 12 shapes are drawn in another Venn diagram. Complete the Venn diagram by labeling the sets and drawing the following shapes. On the Venn diagram, we see that the elements in this region are large in size and the elements in this region are black in color. So we label this set L and this set B. So the large and black circle goes here, and the large rectangle that is not black goes here. Then the remaining black elements go in this region. The remaining elements that are not large and not black are placed outside sets L and B. Show that the exterior angle of a regular octagon is 45 degrees. Here is the formula for the exterior angle of a regular polygon. An octagon has 8 sides, so n is 8. This gives us 45 degrees. Find the interior angle of a regular octagon. The sum of the exterior and interior angles of a polygon is 180 degrees. So to get the interior angle for the octagon, we subtract 45 degrees from 180 degrees, which gives us 135 degrees. The diagram shows the route of a boat race. The route is in the shape of a regular octagon, A, B, C, D, E, F, G, H. H is due west of A. Find the bearing of B from A. On the diagram, we've indicated the bearing of B from A. We found the size of an interior angle in a regular octagon to be 135 degrees. And we've been given this angle to be 90 degrees. The sum of the angles at a point add up to 360 degrees. So to get the bearing, we subtract the sum of 90 and 135 from 360. This gives us 135 degrees. Complete this statement. The bearing of C from D is the same as the bearing of blank from blank. On the diagram, we see that CD and GH are parallel. This means the bearing of C from D is the same as the bearing of H from G. Write down the mathematical name of triangle ABH. There are exactly 2 equal sides in triangle ABH, so it is an isosceles triangle. Calculate angle ABH. We found the size of an interior angle in the octagon to be 135 degrees. Base angles in an isosceles triangle are equal. So when we subtract 135 from 180 and divide by 2, we get 22.5 degrees. Work out the bearing of H from B. On the diagram, we've indicated the bearing of H from B. To get angle HBC, we subtract 22.5 from 135, which gives us 112.5. Angles on a straight line add up to 180 degrees. So the bearing of H from B is 180 plus 112.5, which is equal to 292.5 degrees. Each side of the octagon is 1.35 kilometers. The average speed of a boat is 45 kilometers per hour. Work out the time it will take this boat to complete the race. Give your answer in minutes. We can use this formula to get the time duration for the boat to complete the race. The total distance D covered by the boat is 8 times 1.35 kilometers, and the speed V is 45 kilometers per hour. This gives us 0.24 hours. To convert this to minutes, we multiply 0.24 by 60. This gives us 14.4 minutes. Hetty wants to draw a scale drawing of the roots. She chooses a scale of 1:500,000. Has Hetty chosen a suitable scale? Show all your working and explain your decision. Using the scale Hetty has chosen, let's find the length of each side of the octagon, which is 1.35 kilometers on the scale drawing. This is what we are calling y. When we cross multiply and make y the subject, This is what we get. We multiply 1.35 by 10 raised to the power 5 to convert it to centimeters. This gives us 0.27 centimeters. Based on this, our answer is no. Hetty has not chosen a suitable scale because her scale drawing of the roots would be too small. The grid shows three shapes, A, B, and C. Describe fully the single transformation that maps shape A onto shape B. When we look at shape A and its image, shape B, we can tell straight away that this is a translation because both shapes have exactly the same size and orientation. The only difference is that they are located on different parts of the grid. So now all we need to do is to find the translation vector. From the illustration, we see that the translation vector is -7, -4. And so the full description for the transformation is translation by the vector -7, -4. Describe fully the single transformation that maps shape A onto shape C. When we look at shapes A and C, we can tell straight away that this is an enlargement by a scale factor of 2 because each of the sides of the image, which is shape C, is twice its corresponding side in shape A. In this case, the scale factor is positive because both shapes have the same orientation. Now we need to find the center of enlargement. To get this, we connect at least two corresponding points on both shapes. The intersection point of the lines, which is -1, 0, is the center of enlargement. And so the full description for the transformation will be enlargement by a scale factor of 2 about the center, -1, 0. On the grid, draw the image of shape A. After a rotation 90 degrees clockwise, center 6, -3. First, we need to mark the center of rotation, which is the point 6, -3. Then we rotate each vertex on shape A 90 degrees in the clockwise direction about this center. This means if, let's say, we pick this point on shape A, we draw a line from this point to the center of rotation. Then we measure and mark 90 degrees in the clockwise direction from this line. From here, we draw a line from the center of rotation passing through the 90-degree mark. The final step is to now mark the new position of the point on this line such that the distance from its new position to the center of rotation is the same as the distance from the center of rotation to its original position. After repeating the same process for all the vertices on shape A, we are now able to map out the rotated image of shape A. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.